Aeronautical Engineering by Phillip, Beal, and Shannon Sefton. What is aeronautical engineering? It is the designing, developing, testing, and creating of aircrafts and related products. Some things that aeronautical engineers do are work to improve safety, reduce impacts on the environment, increase fuel efficiency, and reduce costs of planes and other aircrafts.
The daily routine of an aeronautical engineer. Engineers occupy full-time jobs, which means they have full hours throughout the week. Project leaders work longer hours due to the extra responsibilities of checking the progress of different projects and testing the current designs. Designs for these projects are typically for improving aerodynamics, propulsion, control systems, or the materials being used to create the aircraft. Many of the firms that an engineer will work for are to produce items for the federal government. The use of computer modeling equipment has increased over time, which requires more office work than before, and less time in the labs.
Colleges for Aeronautical Engineering. The Massachusetts Institute of Technology is the best college in the country for aeronautical engineering. North Carolina State University is the best public school in North Carolina for aeronautical engineering. It is 34th in the country overall. Salary and outlook. The average annual salary for an aeronautical engineer is $87,000. The typical pay range for aeronautical engineers falls somewhere between $70,000 and $111,000. Over the next 10 years, aeronautical engineering is predicted to grow about 6%, which is about average for the growth of careers. Steps to become an aeronautical engineer. It's a 4-step process to becoming one. First, you need a bachelor's degree in aeronautical or aerospace engineering. Then you need to take the fundamentals of engineering test to become an engineer in training. That's when you can begin working under a licensed aeronautical engineer. And lastly, you need to pass the principles of practicing of engineering exam to receive your PE license. Internships with Boeing, Lockheed Martin, and NCDOT are recommended to help you find a job easier. Prerequisites: Calculus 1, 2, and 3, Dynamics and Controls, Physics, Economics, and Statistics.
How is math used with aeronautical engineering? First, it's used for position, velocity, and acceleration calculations. When an aircraft is landing with different velocities, it will experience different amounts of deceleration in its landing gear. Gear that are not designed to support the size of the aircraft during landing will collapse and cause possible deaths on the flight. Second, engineers have to calculate how much lift will be produced by the wings. Producing lift will apply forces to the wings, and if these wings are not built to support the forces, they'll break off of the aircraft. What is the importance of aeronautical engineering globally and locally? The aviation industry is one of the fastest growing industries in the world, and because of this, larger and larger aircraft are required to meet the demand of passengers. And to make larger planes requires larger engines for more thrust, which means larger wings to support larger fuselages. In addition, American airlines are known to be the safest in the world, with the recent Southwest accident in April of this year ending a 10-year streak of 0 deaths while in flight. One equation used with aeronautical engineering is the Bernoulli equation. It states that the pressure energy plus 1/2 times the density, which is represented by rho, times the initial velocity squared, plus density times gravity times the initial height is equal to the pressure plus 1/2 times density times velocity squared plus density times gravity times height. With his equation, Bernoulli stated that as fluid increases in velocity, its internal pressure will subsequently decrease. The airfoil shape that is used to design all aircraft wings produces this effect as air moves over the upper camber of the wing and is forced to speed up, thereby reducing the pressure. This lack of pressure sucks the wing upwards, causing lift. Although the effect is minimal, it It is a force that must be taken into account during the design of a wing.